All right, let's dive in. We're tackling ocean movements this time. Waves, tides, currents, all those things that make the ocean, well, the ocean.
It's way more complex than most people realize, actually.
And that's why we're here. We've got Kiji213.pdf as our guide. This document is packed with, it's got all the details on how these movements work. It's pretty fascinating.
Definitely. Plus, what's cool is how interconnected everything is. Like, you can't really talk about waves without eventually talking about tides and currents, too.
Right. It all kind of blends together. But let's start with something familiar. Waves. I mean, everyone loves a good beach day, right?
Of course.
Just standing there, watching those waves roll in, crashing on the shore. Seems pretty straightforward. Water moving from point A to B.
See, that's where things get interesting. Our source document actually says that what we see as a wave is actually energy moving across the surface.
So hold on. It's not the water itself that's moving across the ocean.
Nope. Think of it like those stadium waves at a football game. The fans stand up and sit down, creating the wave, but they're not actually traveling along the seats.
Oh, okay. I get it. So it's the energy that's moving, not the water molecules themselves. They're just kind of bobbing up and down as the wave passes through.
Exactly. And that energy can travel for like thousands of kilometers.
Thousands, really.
Yeah. They might start in a storm way out at sea and then keep going until they hit a coastline like halfway across the world.
That's crazy. So those choppy little waves I see on a windy day are those like baby waves just getting started on their big journey?
You got it. And as they travel, they can change. Like, they might start out all choppy and then turn into those smooth rollers you see further out.
So cool. But okay, let's zoom in a bit. The source document actually breaks down like the anatomy of a wave.
Oh, yeah, the different parts.
It's kind of like a mini science lesson, but it's actually helpful.
Right. Like, if you understand the wavelength, which is the distance between the crests, you can start to see why some waves are gentle and others are those massive ones surfers love.
Okay, so give me the crash course. What are the key things we need to know about a wave?
Let's picture a surfer riding a wave. The highest point, where the surfer's hanging 10, that's the crest. The dip before the next wave comes along, that's the trough.
Gotcha.
The distance between those two, that's the wave height. And the distance between two crests, that's the wavelength.
Okay, makes sense. So what happens when a wave gets close to shore? Why do they, like, crash and break the way they do?
That's because of friction. As the wave gets closer to the shore, the bottom of the wave starts dragging on the seafloor.
So it's slowing down.
Right. But the top of the wave keeps going at the same speed, so the wave gets steeper and steeper, and eventually, boom, the top topples over.
And that's the sound of summer. But now let's switch gears a bit. From wind-driven forces to something even bigger, the moon's influence on our oceans. Tides. We all know they rise and fall, but honestly, I never really understood why.
It's all about gravity. The moon's gravity pulls on the ocean, creating bulges of water on the sides of the Earth closest to the moon and farthest from the moon.
Oh, okay. So those bulges are the high tides.
Exactly. And then the low tides are in between those bulges. But the sun's gravity also plays a role, too.
Right. It can't be just the moon, right? The sun's massive.
Absolutely. It's like a cosmic dance. Sometimes the sun and the moon's gravity work together, and sometimes they work against each other.
So how does that affect, like, the tides we see?
Well, when the sun, earth, and moon are all lined up, their combined gravity creates extra high tides called spring tides. And then, when the sun and moon are at right angles to each other, their gravity kind of cancels each other out, so we get lower high tides called neap tides.
So basically, if I want to see some seriously impressive tides, I need to go to the beach during a spring tide.
Yeah, you'll definitely see a bigger difference between high and low tide then. And speaking of impressive tides, have you heard of the Bay of Fundy in Canada?
I think so. Is that the place with the crazy high tides?
It is. The tides there can reach like 15 or 16 meters. That's, well, imagine a 5-story building.
Wow. That's got to be a sight to see. Okay, so I got to ask. The source mentions ebb and flow when it talks about tides. What's the difference?
It's simple, really. Ebb is when the tide is going out, the water level is dropping, and flow is when the tide is coming in. The water level is rising.
So it's like the ocean is breathing, in and out. Wow. It's amazing to think that something as big as the ocean is controlled by something so far away, like the moon. But now, let's move on to our final ocean phenomenon, currents.
Currents?
These are like massive rivers flowing within the ocean.
Yeah, like underwater highways. And they're affected by a ton of things like solar energy, wind, even the Earth's rotation.
Right, the Earth's rotation, how does that play into it?
It's called the Coriolis effect. It's a bit tricky to explain, but imagine you're walking in a straight line on a spinning merry-go-round. You wouldn't actually go in a straight line, would you?
I guess not.
Right, you'd curve because the merry-go-round is spinning beneath you. That's what happens to ocean currents. The Earth spins, so the currents curve. In the northern hemisphere, they curve to the right, and in the southern hemisphere, they curve to the left.
So it's like an invisible force is pushing them off course.
Exactly. And on top of that, we have different types of currents. Surface currents are driven by wind, and deep water currents are driven by differences in water density.
Density, like how much stuff is packed into the water.
You got it. Imagine 2 glasses of water, one with salt and one without. The salty water is denser because it has more stuff packed in. So in the ocean, cold, salty water sinks and warm, fresh water rises. That creates this constant circulation. Deep currents flow from the poles to the equator, and surface currents flow from the equator to the poles.
Whoa, okay, that's a lot to take in. It's incredible how all these different things work together. Wind, gravity, the Earth's rotation, it all comes together to create this giant, complex system of ocean movement.
It really does. And we're only just beginning to understand all the ways these movements affect our planet and us.
We were talking about currents before, like how they can actually help clean up estuaries. That's pretty cool. But are there any other ways that these movements, tides and currents, actually help us, like directly benefit people?
Oh, yeah, for sure. Think about navigation, like for ships.
Oh, yeah, that makes sense.
Sailors have had to understand tides for a long, long time.
To avoid running aground.
Exactly. Especially in shallow waters, you really need to know if the tide is coming in or going out.
Otherwise, you're stuck.
Yeah.
So besides helping ships get around, what else? What can we learn from studying these movements?
Well, our source, Kiji213.pdf, talks about some really interesting things, like, did you know that tides can be used to generate electricity?
Really? How does that work?
They have these power plants called tidal power plants that use the rising and falling of the tides to turn turbines.
Wow, so it's like capturing the power of the ocean.
Pretty much. And it's renewable energy, which is a big plus.
That's amazing. So we're not just learning about how the ocean works, but how we can use it in a sustainable way.
Yeah.
Cool. What else does the source say?
Well, it also mentions that studying ocean movements can give us clues about the health of our planet. Remember how we were saying currents help to distribute heat all around the globe?
Yeah, like it's a giant, what did you call it? A planetary thermostat.
Exactly. So by looking at changes in ocean temperatures and how currents are flowing, scientists can get a better understanding of climate change and how it might be affecting things.
So monitoring these currents, it's almost like taking the planet's temperature. That's kind of important, I'd say.
It is, and it just shows how everything's connected. What happens in the ocean doesn't stay in the ocean. It can affect our weather, our coastlines, everything.
You're right. It's not just a pretty backdrop for a beach vacation. This is serious stuff. Okay, earlier we were talking about the Coriolis effect. Can we go back to that for a second? I'm still a bit confused about how the Earth's rotation makes currents curve.
It is kind of weird to think about. Imagine you're on a merry-go-round that's spinning really fast.
Okay, yeah.
And you try to throw a ball to your friend on the other side.
I bet it wouldn't go straight.
Exactly. It would look like it's curving because the merry-go-round is moving underneath it. That's basically what happens to currents. The Earth is spinning, so as they flow, they curve to the right in the northern hemisphere and to the left in the southern hemisphere.
So it's like the Earth's rotation is like an invisible hand guiding them.
You could say that, and it all adds to the complexity of how our planet works, and that complexity also affects marine life.
Right. We mentioned how currents can impact fishing, but are there other ways they affect the ecosystem, like all the creatures living in the ocean?
Definitely. You can think of currents as transportation for marine animals. They can help them travel long distances, like during migration.
Oh, so a baby sea turtle might use a current to get to where it needs to go.
Exactly. And there are places where warm and cold currents meet, and that creates a ton of nutrients. So you get all sorts of life there, fish, whales, everything. It's like a big underwater party.
That's so cool. But speaking of currents moving things around, the source also mentioned something about plastic pollution.
Unfortunately, yeah, currents can carry pollution, including plastics, all over the place.
So even if I live far from the coast, the plastic I use could end up harming animals in the ocean. That's scary.
It's true. It really shows how connected we all are.
Definitely a good reminder to be more careful about what we use and throw away. Our choices matter. This deep dive is really making me realize how important currents are, not just for the ocean, but for the whole planet.
They're crucial. They're like the lifeblood of the ocean, keeping everything moving and connected. And speaking of connections, remember we mentioned how currents can affect coastal temperatures. That actually has a big impact on the weather.
Right, right. So how does that work?
Well, picture a warm current flowing along the coast. It's like a giant heater warming up the air above it.
Oh, so that's why some coastal areas have milder winters than places further inland.
You got it. For example, the Gulf Stream, which is this big warm current in the Atlantic, helps keep Western Europe warmer than other places at the same latitude.
So those warm currents aren't just nice for swimming, they actually help shape the climate of entire continents. That's wild.
It is, but of course those systems are delicate. Things like climate change can disrupt them.
Right. So are there any worries about how climate change might be affecting currents?
Yeah, definitely. Scientists are keeping a close eye on a few things. One is how melting glaciers are adding a lot of fresh water to the ocean.
So that could mess with the saltiness of the water.
Exactly, and that could slow down or even change the direction of those deep water currents we were talking about.
And what would happen then?
Well, it could change how the ocean absorbs and distributes heat, which could make global warming even worse.
Oh, no.
And it could also lead to more extreme weather, like stronger storms, droughts, floods, all sorts of things.
That's not good. So is there anything being done to address this?
Well, scientists are working hard to understand how these systems work and how they might change in the future. And of course, tackling climate change by reducing emissions is crucial.
It sounds like there's a lot at stake here. We need to protect those currents, not just for the sake of the ocean, but for everyone.
Absolutely. It's all connected. Our actions have consequences, and we need to be aware of that. We've covered so much already. It's incredible how it all ties together. But before we get lost in the big picture, I want to bring it back to something a little more down to earth. The source actually mentions how currents affect something we all care about: food.
Oh yeah, you mean fishing.
Right. Remember how we were talking about those areas where currents collide or where they bring up cold, nutrient-rich water from the deep? Those areas are like magnets for fish.
So if those currents change because of climate change, that could mean less fish for us to eat.
Exactly. That's why understanding these currents is so important for managing fisheries sustainably, making sure there are enough fish for everyone.
It's a delicate balance, isn't it? Between our needs and the needs of the ocean.
Definitely. We need to be respectful of the ocean and how it works. Our future depends on it.
This whole deep dive has really opened my eyes. It's easy to forget that even if we don't live near the ocean, what we do still has an impact.
That's true. We're all connected to the ocean in some way.
Well, I'm definitely feeling more connected now than I did before. I'm actually eager to learn more.
There's always more to learn.
Welcome back for the final part of our deep dive into ocean movements. We've learned a ton from Gigi213.pdf, but I feel like there's still so much more to uncover.
You're right, there is. Oceanography is full of mysteries. There's always more to learn and discover.
So what are the big questions that oceanographers are still trying to figure out? What are they losing sleep over?
Well, a major one is how climate change is going to affect those deep water currents we were talking about. The ones driven by differences in water density.
Yeah, like a giant underwater conveyor belt.
Exactly. And we're already seeing some potential issues with this conveyor belt because of all the fresh water melting from glaciers and ice caps.
So it's like dumping a ton of fresh water into a perfectly balanced saltwater system.
Perfect analogy. That influx of fresh water can really mess things up. It throws off the balance, and that could slow down those deep currents, maybe even change their direction.
Okay, so what would happen if those currents changed?
Well, one thing is, those currents play a huge role in moving heat around the planet. If they slow down or shift, it could really mess with the global temperature.
Oh, so it could make climate change even worse.
Potentially, yeah. And it's not just about temperature. Those currents also carry nutrients and oxygen, which are essential for marine life. If those currents get disrupted, it could have a domino effect on the whole ecosystem.
So it's not just about some currents changing. It could impact the whole web of life in the ocean.
Exactly. Everything's connected. That's why understanding these ocean movements is so important. It's not just science for the sake of science. It's about understanding the systems that keep our planet alive.
Wow. There's a lot to think about.
Mm-hmm.
But are there any, positive developments in oceanography? Any new tools or discoveries that are giving us some hope?
Oh, yeah, for sure. Like advances in underwater robotics and sensors, those are letting us explore the ocean in completely new ways. We're getting a much better look at deep sea ecosystems, mapping currents with more accuracy, and even tracking plastic pollution as it moves.
So even though we're facing these big challenges, we're also finding new ways to learn about them and maybe even find solutions.
Exactly. Plus, there's a growing awareness of just how important ocean conservation is. More and more people are realizing that a healthy ocean means a healthy planet.
And that's where we all come in, right?
Yeah.
It's not just up to scientists and governments to fix things. We can all make a difference.
Absolutely. Even small changes can add up, like reducing our carbon footprint, choosing sustainable seafood, even just talking to people about how important the ocean is.
You know, this whole deep dive has really reminded me of just how amazing the ocean is. It's easy to get caught up in the problems, but we shouldn't forget the beauty and mystery of it all.
I agree. The ocean is truly fascinating. It's like every time we dive in or do some research, we discover something new and incredible.
I think that's a perfect note to end on. Even with the challenges, there's still so much to wonder at and appreciate about our oceans.
Well said. And remember, the ocean is not just some separate thing, it's a part of us, it connects us all.
Huge thanks to our expert for guiding us through this incredible deep dive. And to our listeners, we hope you've enjoyed exploring the fascinating world of ocean movements with us.
Keep learning, stay curious, and let's all do our part to protect this amazing blue planet we call home.
Until next time, stay curious.